Hello everyone, I'm Zach. I work at the Macromolecular Crystallography beamlines at this light source, and I'm here to make a demonstration of the SmarGon that was recently installed at our beamline X06SA. So we have here, I'll briefly explain what you're looking at. So we have a view of the SmarGon device itself here on the top left. Next there's a close-up view from a different angle of a sample that's currently mounted. In here we have our GUI, that's the GUI that the user uses to prepare the experiment. You can see the sample here. On the top right we have our TEL GUI. That's the GUI that we use to mount samples that we have imported with the spreadsheet. Here this little thing is a launcher that you can use to start different applications. Usually this little guy here is on the top right corner. And in here, this browser is showing the data processing tracker that we have. So as we collect data, we have automatic data processing. And as the data is processed in the background, the results are being displayed in this window. The green window here in the bottom, that is the software that actually orchestrates the data acquisition. The GUI is used to prepare the experiment, and as soon as the user clicks the Start Data Acquisition button, it generates a scan request which is sent to the data acquisition server in the green window. Alright, so interacting with the SmarGon. So usually we have buttons on the GUI on this side that we can use to turn the sample as you see fit, 45 degrees or 90 degrees or 10. There are shortcuts, so to prevent the scientists from having to look away from the sample and miss maybe important things, we have shortcuts. So the most important is the scroll wheel, like this. The scroll wheel on its own will rotate 90 degrees. And the scroll wheel with the shift key down will rotate by 10-degree steps. So you can fine-tune the orientation. With the control key you can rotate by 180 degrees. Clicking any part of the sample will move that part of the sample onto the beam. The beam can be seen here as a little yellow square. We can zoom in a little bit. Now you see that we have a larger square because we're magnified the microscope image. And this represents roughly the shape of the beam when it hits the crystal. Alright. Since we're talking about the SmarGon, the SmarGon has two additional angles that can be changed. Yes. The chi angle is this motion here. I'm going to move it to 40. And you can see the motion happening. In here. Let me move the angle now to 0, and you can see again what the chi motion is. You should be looking here. Right. And the phi angle is a little rotational stage that's at the very end of the SmarGon. So in this area here. That's the phi angle, is the stage that holds the magnet, that holds the sample. So we can rotate this as well. When chi is at 0, this angle is rotating in the same way as omega, but this is not the data acquisition axis that we have. When we collect data, we use the omega angle. So let's go back to 0. We can put the lamp back up so we can have a nice look. Nice view of the sample. Very good. There we are. Now, When dealing with the SmarGon, on top of using these widgets to change the angle, you can also use the key combination Control-Shift in the scroll wheel. With the Control-Shift and the scroll wheel, you can step the chi angle by 1 degree steps. The SmarGon is very fast. I think the top speed for the chi is like 15 degrees per second, and you can see that it responds almost in real time as you change the chi angle. The chi angle and the phi angle, the phi does not have a shortcut at the moment, it needs to be implemented. They can be used for different reasons, of course. One of them is to maybe avoid a cracked part of the crystal. So if the crystal has a crack, and you can reorientate the crystal to avoid having the beam go through the crack during data acquisition, this is something that you can do with these angles. And the other usage of this is if you have a P1 space group and completeness is not always guaranteed, you can collect multi-angle data sets with this to increase the completeness of your data. The very basic data collections are the same as before. You just align your crystal how you see fit, and then if you want to change the angles, you change the angles. Once the angles are changed, they stay put during normal data acquisitions. So in this case, I can just say start, and it sends a scan request. So now the little green window here is taking over, and it prepares the data collection and carries out a 90-degree sweep using the omega stage. In here you can see the images, the diffraction images are being updated, an image every 2 seconds, more or less, just so you can keep an eye on what's going on. At the same time, the data processing software has already received the information about the data set that was collected, and it starts now waiting for the data files so it can start doing the data processing for you. Regarding collecting data in different ways, we have an option of splitting the radiation dose across different positions of the crystal. And we do this by adding these bookmarks here. So you pre-align the positions. I think I should remove them all first, because I had pre-old positions over there. So you can right click and add a bookmark to a position. You have to make sure it's centered first. You go to the next position, make sure it's centered. You can add by using the B key on the keyboard. It's a shortcut. So you can do another one. Good, B. So we have 3 positions, that should be enough. Now when I click, I'm gonna put 90 degrees here as well. When I check this option that says split data sets into defined bookmarks, what it means is that it's going to collect this total range split into these 3 defined positions. So in this case, it's going to collect 30 degrees for each part of the crystal. The one thing to note about this is that the data set will look as if it had been collected in one position only. And the data processing software will also see this. So you just split the radiation dose across different parts of the crystal, and you end up with one single data set. So let's do this again. The same data set. You will notice I will increase the front light so you can see the crystal, and you will notice that the crystal will shift. There you go. For each position. After it shifts, it goes back a little bit and starts again for the following 30 degrees. There. And as you can see, this data set here was the one with only one position. So that's 900 frames, oscillation angle, it's all the same. And in this one, it's also exactly the same. So for all purposes, this is a single data set, even though it was collected in 3 different parts. You will notice in the scaling factors of the data processing that there might be jumps. And this is when it shifts to a different part of the crystal. For instance, going from position 1 to position 3, there's a large difference in crystal volume that is diffracting. So you'll see difference in scaling factors there. All right. Let's delete all of these again. And now I'm going to set these angles to 0. And now what we're going to do something different. We are going to collect, we're going to make again bookmarks. But this time we are going to change the chi angle and the phi angle for each bookmark. So independent of what chi or phi you have, aligning the crystal is always the same. So again, another position here, and now in here as well, and I'm going to go to chi 40 and phi 87. 87 is always a good number to go. Yeah. Very good. So now you see that the checkbox changed from split data into defined bookmarks to collect multi-orientation data sets. So for this data acquisition scheme, instead of dividing the total range of degrees into each bookmark, the software is going to collect 90 degrees at each position. So you're having then 3 different data sets in this situation. Oh, I didn't put the bookmark here yet. There. Very good. Now I have 3 bookmarks. 2, 3. Different chi angles and different phi angles. You can put whatever combination you want, as long as it's within the limits. So again, we're going to start data collection. There we go. Now we should go to the first position. Very fast motion. There's little overhead in going from one position to the next. And this is going to be then 90 degrees. So in the meantime, let's talk a little bit about the sphere of confusion. So the SmarGon, the way it was calibrated, is giving us roughly better than 4 micrometer sphere of confusion when you have a high chi angle in the sample, and if you have chi equals 0, then you have a sphere of confusion of roughly 1 micron. The chi motion itself has a sphere of confusion of 5 microns roughly, so it's a very precise device. So you can trust the device is going to stay put when you're changing these angles. The sample is going to stay put in front of the beam as you're changing these angles. Of course, if you have a much smaller beam and a micron-sized samples, that might be a bit challenging. One needs to take these things into account. So as you see here, we're now collecting on the data processing tracker. You can see that we have now different data sets being collected. There we go, goes to the next one. So this way of collecting data for multiple chi-phi angles is also the method that you would use if you want to collect native SAT data, for instance. So if you have very low energy, you can use this method to collect very redundant data to try and phase your crystal like this. Right. Yeah. So because the SmarGon is so precise and reliable, we will have soon in the GUI a way in which you can actually just tell the software collect 5 different chi angles and 10 different phi angles for this crystal, and it will do so automatically without the user having to change or create bookmarks for each of the combinations. This feature is already available when the data acquisition is requested from our automation software, the SDU. Okay, I think we're almost done with this data acquisition. Oh, and I'm collecting 360 degrees of data, which is why it's taking so long. All right, we let it go. We see they were having very nice data. So at the very end of the data processing, all of these three data sets will be merged together. So you will end up with a very complete result. I think that's all the time I had. So if you have questions, please shoot a comment or put them in the chat. Thank you very much.